Section 5.3, we can continue with some probability rules. Now we're going to go into conditional probability and the multiplication rule. So let's start with conditional probability. We've actually discussed these before and worked with them before in chapter 1 when we talked about conditional distributions. The probability that one event happens given that another event is already known to have happened is called a conditional probability. Suppose we know that A has happened, then the probability that event B happens given that event A has happened is denoted as the probability of B given A. So this little bar kind of indicates a given. This is the given, and then we're calculating the probability that B occurs given A has occurred. So to find these probabilities, we use the following formulas. This formula is on your note sheet. Basically, it's the probability that A and B happen divided by the probability that B happens. So the conditional portion goes on the bottom, and then the top it's A and B. And this is the same formula, just switch the A's and B's around. Example, who owns a home? Here's a two-way table from the homeowner we worked with before. The homeowner data we worked with before, I should say. So it's basically high school or not a high school graduate, and then do you own a home or do you not own a home? Find the probability a randomly selected person is a high school graduate. So this is a probability that someone is a high school graduate. This is not a conditional probability, just a straight probability. High school graduate, that would be 310 out of 500. Which is 31 out of 50, which is 62%. Find the probability a randomly selected person is a homeowner and a high school graduate. Probability that they're a homeowner and a high school graduate. Well, how many people were both homeowners and high school graduates? That would be this many people out of the total. I guess I should fire up the calculator just so I can. You can leave them as fractions. I do prefer that if you're going to leave them as a fraction, you leave it as a reduced fraction. And I don't know. I don't think there's anything that goes into both of those. But it's not a bad idea to just, you got your calculator for every problem. We could just type it in and get our decimal proportion. Apparently my calculator is a little slow to boot up here. Sorry. So 221 out of 500. 221 out of 500. 442. 0.442. Find the probability a randomly selected person is a homeowner given, so that given keyword there tells us that we have a conditional probability, given that the person is a high school graduate. So this is a probability that you're a homeowner given you're a high school graduate. There's kind of two ways to calculate this probability. We can use the actual formula. So I think I'll do that first just to illustrate it. It's the probability that you're a homeowner and you're a high school graduate divided by the probability you're a high school graduate. So now you can see kind of why I asked you to calculate these two things to set it up. So this is homeowner and high school graduate, that's 0.442. High school graduate, that's 0.62. So if we take 442 divided by 62, it gets us 713. There is another way to calculate it, kind of a more conceptual way. I mean, we have our table of values. We can just think about what's the probability somebody is a homeowner given that they are a high school graduate. So if you only select from people that are high school graduates, basically just pretend your data set doesn't even have these other values and you're just looking at this distribution. So given that you're a high school graduate, there's a total of 310 people. Find the probability that you are a homeowner. So that's 221 out of 310. And if you type in 221 out of 310, you'll see that you get the exact same answer. So you guys may say, well, that's easier. Then go ahead and do it that way. You don't need to use a formula. Formula is just there if you want to use it or if it makes things easier. If a person is not a high school graduate, then what is the probability they own a home? If the person is not a high school graduate, then what's the probability they own a home? So I want to find the probability that they own a home if the person's not a high school graduate. So that is given they're not a high school graduate. So again, I could use a formula here, but I think I can just maybe go the easier route and kind of do it intuitively. So given they're not a high school graduate, so if I only consider this group of people, there's 190 people, and 119 of them own a home. So 119 over 190. Control, enter, 626. Okay. That's it. I guess I just feel obligated to comment. If you're a high school graduate, the probability that you own a home is 731. If you're not a high school graduate, the probability you own a home is 626. You know, it's exactly the fact that these two things are different that tells you there's a, I think the way we would say it before is there's a relationship between home ownership and whether you graduated from high school or not. And we're going to call it a little something different here today. We're going to say these are not independent later on here, but we'll wait for it. Another example, newspaper choice. 40% of people at the John Cooper School read the New York Times, 25% read USA Today, and 5% read both. I think probably in reality these percentages are much lower right now. We should probably talk about internet newspapers, but maybe this could be on the internet, right? If we randomly select a person that reads the New York Times, find the probability they read the USA Today. Alright, so if we randomly select a person that reads the New York Times, so given we have a New York Times reader, find the probability they read USA Today. So I want the probability they read the USA Today, given they are a reader of the New York Times. Alright, so do we want to try to do this intuitively or use a formula? To be honest, I'm not real sure what to do with these numbers intuitively. Maybe some of you guys can figure it out. More power to you. So I'm going to go to the formula. Formula is, you do the AND of both events on top, and then you do the probability of the given on the bottom. So this is a probability that you are a USA Today reader and a New York Times reader, divided by the probability you are a New York Times reader. So what's the percentage of people that read both? Well, that's 5% that read both. What percent read the New York Times? Well, that's 40%. So, and I'm thinking some of you guys might have been able to kind of put it together. Of the 40% of the people that read the New York Times, 5% of them read both. So that's 5% out of 40%. I should probably be able to do this, but is that 1/8? 1.625? I don't know. Divided by 0.4. 125, 625, yeah. See, that's why I don't do math in my head. 125. Basically 1/8, right? 1/8 of the people that read the New York Times are also USA Today readers. So here's a case where the formula, I think, is very helpful. Just prevents you from having to think about it more than you need to. Find the probability that A and B occur. Finding the probability that A and B occur. Use the general addition rule and the formula for conditional probability to develop two formulas for calculating probability of A and B. There are no formulas on the formula sheet for calculating A and B. However, those show up in both the general addition rule, which is the probability of A. I could use the word or. I'm going to use the word or B is the probability that A happens plus the probability that B happens minus the probability that A and B happen. So because this formula, technically it's the formula for the or, but because it has this in it, we can derive a formula for calculating the sum. So let's just move this over to the other side of the equation and move this over there. So the probability of A and B occurring is equal to the probability that A occurs plus the probability that B occurs minus the probability that A or B occurs. So here's one formula for calculating probability A and B occur. And it kind of looks like, it looks like the addition rule, but it's, I don't know, I guess you got to be a little bit careful. Don't start thinking that ands are addition, because they're not. Ors are addition, but if you have this and you want this, you can use this equation to solve it. So the other one is the conditional probability. The probability that A given B occurs is equal to the probability that A and B occur divided by the probability that B occurs. So if I solve this for this right here, basically just multiply both sides by the probability of B. So this becomes probability that, I'm going to reverse the order, probability that B and A occur, it doesn't really matter, is equal to the probability that B occurs times the probability that A occurs given B has occurred. This is kind of the more common formula for calculating an AND. Basically, if you want to know the probability that two things happen, you take the probability that the first event happens times the probability the second event happens given that the first event has happened. For me, this formula is kind of the most sensible, maybe even more so than this one here. And I didn't really even talk about where this formula comes from. I just kind of presented it to you. But if you were to ask me to kind of talk about where this formula comes from, I'd probably start right here because this here makes sense. This is called the multiplication rule. So this is called the general multiplication rule. The probability of two events both occurring can be found using the general multiplication rule. Probability of A and B is simply that. Okay? All right. However, don't forget that there are three ways to calculate the probability of A and B. The general addition rule formula. That's probably the least used, I would say. You don't often use this formula for calculating an AND, but you could use it. The conditional probability formula, that's this one here that I just did, which I kind of like. And just kind of figuring it out intuitively. If you recall, we'll get to that later. Intuition is always an option for solving probability problems. You just got to be careful with it. Okay. This next example is a little bit big. We're at 13 minutes, so I think this is a good time to stop. Next video we'll pick up with some more examples.